The day the sky went silent. It began with a sound no pilot ever wants to hear. Silence. Not the peaceful quiet of a calm morning, but the kind of silence that feels wrong, unnatural, like the world itself just held its breath. On a normal day, US Air Force flight lines are alive with noise. The thunder of jet engines spooling up. The metallic clang of maintenance crews working on airframes. The constant chatter of radios coordinating dozens of operations simultaneously. The hydraulic whine of weapons being loaded. The rumble of fuel trucks moving between aircraft. It's organized chaos, a symphony of military precision playing out across miles of concrete and steel. But on this particular morning, that symphony ended in an instant. This is the story of the day the sky went silent. Act 1, The Morning Routine. March 15th, 0547 hours. One of the largest Air Force installations in the United States. I can't tell you which one. Operational security means certain details remain classified. But what I can tell you is this. This base is home to over 15,000 personnel. It operates 24 hours a day, 365 days a year. On any given day, between 40 and 60 aircraft launch from these runways. Fighters, tankers, cargo transports, reconnaissance platforms, trainers. This isn't just an airfield. It's a logistics hub, a command center, a critical node in America's global military network. Staff Sergeant Marcus Chen had been working the night shift. His crew was responsible for pre-flight inspections on 6 F-16 Fighting Falcons. Standard procedure: check the airframe for stress fractures, verify hydraulic systems, test avionics, inspect weapons hardpoints, sign off on fuel loads. Everything by the book. Everything exactly as it should be. 300 yards away, in the control tower, Senior Airman Jennifer Park was beginning her morning shift. She'd been an air traffic controller for 4 years. On this morning, she was responsible for coordinating the launch sequence for 12 aircraft scheduled to depart between 0600 and 0700 hours. 4 F-16s heading to a training range in Nevada. 2 F-22 Raptors joining a multi-role exercise. 3 KC-135 tankers deploying for aerial refueling support. 2 C-17 Globemasters carrying cargo to an overseas base. 1 E-3 Sentry AWACS heading out for a surveillance mission. In the squadron-ready room, Captain Tyler Morrison was going through his pre-flight checklist. This would be his 47th combat training sortie. He'd flown F-16s for 6 years. He knew his aircraft better than he knew his own car. Every switch, every system, every contingency procedure. His mission today, air-to-air combat training. 2 hours. Standard exercise. Nothing unusual. Across the base, the morning routine continued. Maintenance crews worked under floodlights. Security forces ran perimeter patrols. Supply personnel staged equipment. Cooks prepared breakfast for thousands. Medical staff ran shift change. Intelligence officers analyzed overnight reports. Meteorology techs prepared weather briefings. It was a perfectly choreographed operation, the result of decades of doctrine, training, and experience. At 0558 hours, everything was on schedule. The first aircraft was set to launch in exactly 7 minutes. All systems showed green. All crews reported ready. All aircraft were mission capable. It was shaping up to be a routine day. And then, Act 2, the failure. 0559 hours and 23 seconds. Senior Airman Park was coordinating with departure control, confirming clearances for the first launch. Her radar screen showed the positions of all active aircraft, 3 helicopters doing pattern work, 2 jets taxiing to the runway, and the ambient air traffic in the surrounding airspace. Everything normal. 0559 hours and 47 seconds. Park noticed something odd. Her primary radar display flickered. Just for a second. Then it stabilized. She made a mental note to report it to maintenance after the launch sequence. Minor glitches happen. 0600 hours exactly. The screen went black. Not flickering. Not frozen. Black. But it wasn't just her screen. Every radar display in the tower went offline simultaneously. The backup systems. The secondary frequencies. The emergency backup radar. All of them. Gone. Park felt her stomach drop. She immediately reached for the radio to contact base operations. Standard procedure for equipment failure. Reported. Switch to backup systems. Maintain operations. She pressed the transmit button. Nothing. No static. No squelch. No carrier tone. Dead air. Around her, other controllers were discovering the same thing. UHF radios, offline. VHF radios, offline. Encrypted tactical channels, offline. Emergency frequencies, offline. Landlines to base operations, no dial tone. Satellite communications, no signal. Even the internal intercom system within the tower, silent. The watch commander, Lieutenant Colonel Sarah Vance, realized what was happening. This wasn't a simple equipment failure. This was a system-wide communications collapse. And they had 12 aircraft about to launch, with no radar, no radio, and no way to control them. Vance grabbed the emergency procedures manual. She flipped to Section 7, Communications Failure Protocols. But this scenario wasn't in the manual. Because this scenario wasn't supposed to be possible. The system had redundancies. Triple backups. Physically separated networks. Hardened infrastructure designed to survive everything from power outages to electromagnetic pulses. And yet, complete failure. 0601 hours. They'd been offline for 60 seconds. On the runway, Captain Morrison's F-16 was next in line for departure. He was waiting for clearance to take the active runway. But the clearance never came. Morrison tried his radio. Tower, Viper 2-1, request clearance for departure. Silence. Tower, Viper 2-1, radio check. Silence. He switched frequencies. Guard frequency, dead. Squadron frequency, dead. Ground control, dead. Across the base, other pilots were experiencing the same thing. No radio contact. No tower communications. No ground control. No clearance to move. But they didn't know why. Had their radios failed? Had the tower's equipment failed? Was this an exercise? An attack? On the flight line, aircraft sat motionless. Engines running. Pilots waiting. Ground crews confused. And in the tower, panic was beginning to set in. Lieutenant Colonel Vance made a decision. Without communications, she couldn't order the aircraft to stand down. But she couldn't let them launch blind either. She sent 2 controllers running, physically running, to alert base operations in person. In 2024, with all our technology, they were reduced to messengers on foot. It took 3 minutes for the controller to reach base operations. 3 minutes that felt like hours. Act 3, the crisis escalates. 0604 hours. Base Operations Center. Brigadier General Robert Hawkins commanded this installation. A 28-year veteran. 3 combat deployments. He'd handled emergencies before. But nothing like this. The situation reports were flooding in. Tower, all communications down. Flight line, aircraft unable to receive clearances. Maintenance operations, no radio contact with crews. Security forces, encrypted radios non-functional. Command post, satellite links offline. Intelligence center, data feeds terminated. Weather station, unable to transmit updates. But it was worse than just communications. The IFF system, identify friend or foe, was offline. This system is how military aircraft identify each other. How they distinguish between friendly and hostile aircraft. How air defense systems know not to shoot down their own planes. Without IFF, every aircraft is potentially hostile. And here's where it gets truly dangerous. This base was protected by multiple layers of air defense. Patriot missile batteries. Short-range defense systems. Fighter patrols. All automated. All designed to respond to threats within seconds. And all of them suddenly unable to identify friendly aircraft. General Hawkins grabbed a hardline phone, a physical landline that didn't depend on the base network. He called North American Aerospace Defense Command. NORAD. The conversation lasted 4 to 5 seconds. This is General Hawkins, Commanding Officer, Redacted Air Base. We have experienced complete communications failure across all systems. All aircraft operations are suspended until further notice. We have 12 aircraft on ground awaiting departure, holding in place. We have no radar coverage. We have no IFF capability. We are requesting immediate support from regional air defense to monitor our airspace. Consider this a potential hostile action until proven otherwise. Within 90 seconds, NORAD had alerted neighboring air bases, diverted 3 air defense fighters to provide overwatch, established a no-fly zone over the affected base, elevated the threat level for the entire region, contacted the National Security Agency to investigate potential cyber attack. This was no longer just a base problem. This was a national security incident. 0607 hours. Back on the flight line, pilots still didn't know what was happening. Captain Morrison could see ground crew running between aircraft. He could see security vehicles racing across the tarmac. Something was very wrong. But with no communications, he had no way to know what. And no way to know what to do about it. Ground crews began using emergency hand signals. Visual communications developed decades ago, before radios were standard. Arms crossed overhead, stop. Arms waving downward, shut down. Cutting motion across throat, kill engines. It was surreal, watching billion-dollar stealth fighters being controlled like they were crop dusters from the 1940s. One by one, the engines wind down. F-16s. F-22s. The massive turbofans of the KC-135 tankers spinning to a stop. The sound that had filled the morning air, fading. Fading. Until there was only silence. 0610 hours. 13 minutes after the failure began. 50 aircraft. Completely grounded. 0 in the air. 0 able to launch. One of the most powerful military installations in the world, suddenly powerless. Act 4, the investigation. Within minutes, specialized teams descended on the problem. Communications technicians. Network engineers. Cybersecurity specialists. Intelligence analysts. They needed to answer 3 critical questions. What failed? Why did it fail? And most importantly, was this an attack? The base's communications infrastructure was massive. Miles of fiber optic cable. Dozens of server rooms. Hundreds of radios. Satellite dishes. Encrypted networks. Redundant systems designed to survive almost anything. And all of it, dead. The technical teams started working backwards. If the radios didn't work, check the transmitters. Transmitters were fine. Check the receivers. Receivers were fine. Check the power supply. Power was fine. Check the network backbone. And there, they found it. A single piece of equipment. About the size of a refrigerator. Called a CAISI node, Combined Air Operations Intelligence System Interface. You've never heard of it. Most Air Force personnel have never heard of it. But it's the invisible heart of modern air base operations. This node did something critical. It synchronized time across all systems. You see, modern military networks need precise timing. Down to the nanosecond. For encrypted communications to work. 4 radar systems to triangulate positions. 4 IFF transponders to send the correct codes. 4 GPS to provide accurate navigation. 4 weapon systems to coordinate. Everything, and I mean everything, depended on precise time synchronization. And that synchronization came from this one node. At 0559:47, a software module within the CAISI node had encountered a corrupted data packet. The kind of thing that happens thousands of times a day on any network. Usually, the system detects it, flags it, discards it, moves on. But this particular packet triggered a bug, a flaw in the code that no one knew existed. The node tried to process the corrupted data. Failed. Tried again. Failed. And entered what programmers call a crash loop, continuously trying to restart, failing, trying again, failing again, over and over. And because this node controlled time synchronization, every other system that depended on it, which was every system on the base, suddenly couldn't function. Radars need synchronized timing to track targets. Without it, offline. Encrypted radios need synchronized timing to decode messages. Without it, offline. IFF transponders need synchronized timing to broadcast the correct codes. Without it, offline. One node. One software bug. Total systems collapse. The fix, once they identified the problem, was relatively straightforward. Isolate the corrupted node. Reboot it with a clean software load. Bring it back online. Verify synchronization. Restart dependent systems one by one. 0634 hours. 35 minutes after the failure. The first systems came back online. Radios crackled to life. Radar screens illuminated. IFF systems began transmitting. Communications were restored. In the tower, Senior Airman Park heard the most beautiful sound in the world, static. The white noise of an active radio frequency. It meant the network was alive. But they didn't immediately resume flight operations. General Hawkins ordered a complete systems check. Every aircraft. Every radar. Every communications link. Everything had to be verified as fully operational before anyone launched. That verification took 6 hours. The 12 aircraft scheduled to depart at 0600? They finally launched at 1400 hours. 8 hours late. Act 5, the ripple effects. But the impact didn't stop at one air base. Those 3 KC-135 tankers that couldn't launch? They were supposed to refuel fighter aircraft flying from Alaska to Japan. Without tanker support, those fighters had to divert to alternate bases, disrupting their mission timeline by 2 days. The C-17 cargo planes that couldn't depart? They were carrying critical supplies to troops in the Middle East. Medical supplies. Spare parts. Equipment. Their delay meant units in the field went without needed resources. The F-16s that couldn't launch for their training exercise? They were part of a multinational training event involving allied forces from 3 different countries. The entire exercise had to be rescheduled. Dozens of aircraft. Hundreds of personnel. Millions of dollars in coordinated operations, disrupted. The E-3 AWACS that couldn't launch? It was supposed to provide surveillance coverage over a region of interest. Intelligence analysts lost 8 hours of potential data collection. You can't get those hours back. 1 base failure. 35 minutes. But the operational impact rippled across 3 combat theaters. 7 allied nations. 17 different missions. 3 full days. The Department of Defense later calculated the total cost. Direct costs, $4.7 million. Wasted fuel, rescheduled operations, overtime pay, diverted flights. Indirect costs, impossible to calculate. Lost intelligence, delayed supplies, disrupted readiness. Strategic costs, even harder to measure. What if this had happened during an actual crisis? But the most significant cost wasn't financial. It was the realization, the cold, uncomfortable truth, that came from this incident. Modern military power is staggeringly fragile. Act 6, the deeper implications. The United States military is the most technologically advanced fighting force in human history. Stealth aircraft that can't be seen. Precision weapons that can hit a target from 1,000 miles away. Satellite networks that provide global coverage. Cyber capabilities that can reach any computer on Earth. Intelligence systems that process petabytes of data. But all of that power, depends on invisible infrastructure. Networks. Servers. Cables. Software. Synchronization. Systems that no one sees. Systems that no one thinks about. Until they fail. For most of human history, military power was simple. Who had more soldiers? Who had better weapons? Who had stronger fortifications? Victory went to whoever could destroy the enemy's physical assets. But in the 21st century, you don't need to destroy the assets. You just need to disrupt the network that controls them. The Pentagon conducted a study after this incident. Classified, of course. But elements of it leaked to military journals. The findings were sobering. US military bases worldwide have an average of 47 systems that could, if they failed, cause cascading disruptions similar to what happened that day. 47 single points of failure. Per base. Hundreds of bases globally. And here's what keeps military planners awake at night, adversaries know this. China has spent 2 decades studying American military networks. Russia has demonstrated sophisticated cyber capabilities. Iran has shown the ability to disrupt critical infrastructure. North Korea has proven they can infiltrate secure systems. They don't need to match American military power. They just need to find the weak links. The Kaisi nodes. The single points of failure. And exploit them. War games conducted after this incident simulated what would happen if a hostile actor deliberately caused this kind of failure at multiple bases simultaneously. During a crisis. During a conflict. The results were classified. But officers who participated described them with words like catastrophic, unmanageable, existential. The Air Force has since taken steps. Redundant Kaisi nodes. Better software quality control. Enhanced cybersecurity around critical infrastructure. But each fix reveals new vulnerabilities. Each patch covers one hole and exposes another. It's an endless race, defenders trying to secure systems that are, by their nature, too complex to fully secure. Closing. Today, that air base operates normally. Jets launch on schedule. Radios chatter with traffic. Radars track the sky. Everything works. But the personnel who were there that morning, they remember. They remember the silence. The helplessness. The realization that all their training, all their technology, all their firepower, could be rendered useless by a single corrupted data packet. We live in an age where warfare is invisible, fought with code instead of bullets, won by disrupting networks instead of destroying armies. And the battles that will define the 21st century won't be loud. They'll be silent. Because sometimes, the most dangerous weapon isn't the one that makes noise. It's the one that makes silence.